Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Welcome to the second class of, or basically the third class of CS103 computer programming. In this lecture, we'll formally start programming and computer programming. So this is chapter 1 of the book, an overview of computers and programming languages. And I'll basically be going through the basics and basics of computer programming and computer languages, and a brief quick overview of what computers are made for. So let's start without further ado. The first thing, of course, is that how the programming languages have evolved. The earlier computers were programmed in machine language, and machine language was basically had three main commands: load, multiply, and store. So for example, to calculate wages, which is going to be a product of how many hours a person has worked multiplied by the rate per hour. In machine language, it would look something like this, where this command is used for loading some particular data into the CPU. This command is used for multiplying that data with another location or whatever, and then finally storing it in some particular location within the PC. So this was how the original programming language looked like. All of them were basically Boolean programs written in binary language like this, like it has been done here. The main commands here were load, multiply, and store, for example. And within these three commands, most of the things were we were able to perform them. Then I think it was basically from these machine level languages, machine language programming, the programming languages evolved a little bit, and finally we had the assembly language instructions available. The assembly language instructions are basically mnemonic. So an assembler in that regard is basically a program that translates a program written in assembly language into the machine language, the language that we saw earlier. So it's again the same thing. You can use the assembly language instructions to declare, to calculate the wages of a person by using the same formula, rate multiplied by hours. So first, what you can do is you can load the rate, multiply it with R, and then store it as wages. Again, you can see that instead of those Boolean alphabets and Boolean locations, instead we're using English language commands, instructions, and English language variable names to do the same thing. This is assembly language. After assembly language, the higher level languages that were introduc+, they started off with something that is now known as BASIC, Fortran, COBOL, Pascal, C, C++, C#, and Java. The higher level languages, the differentiating factor here is basically the use of a compiler. So if someone asks you what is the difference between an assembly level language and a high level language, my only answer would be that each higher level languages usually use some kind of compiler. And in that sense, the compiler is the differentiating factor. Compiler is a two-step program, which some of you might go on and read about maybe in the compiler's course, if they are offered one, and it might be offered as an elective to you, to the AI students. So you will get a better chance to understand what a compiler is. But for now, it works that just to say that compiler is basically a program that translates a program written in a high-level language into machine language. So in that sense, and the equation wages is equal to rate into hours can be written in C++ as simply wages is equal to rate into hours, where wages, rate, and hours is basically variable names. What is a variable name? We'll discuss that in one of the next lectures. So here's how a C++ program processes. At the top, what you have is what is called the header or the library file. So this is the instruction to the compiler using a hash include that you should include the library file iostream with this code. The iostream file basically contains commands like cout and return, etc. So without iostream, you might not be able to use cout at all. Then within cout, you need to use within iostream, you need to use the namespace std. And if you use it, only then you can use cout directly, as is done over here. So these are the preprocessor directives over here that are given to the processor. So it processes them before actually it starts to run the program. It loads these files, does all these things before it starts to run the code. Int main is your main function. We'll talk about it later when we talk about functions. But this is the place where your actual code can start to run. So for example, this particular piece of program contains the code cout, my first C++ program, and L return 0, and it finishes here. And if you run it, you're basically going to see my first C++ program, full stop, that's it. So what has happened? What has happened is that this is written in C++, a compiler for C++ is used to compile this program, and after compilation, it is executed. The compiler basically checks that there's no syntax errors here, and it may also check at runtime when you execute it. It then checks that, or basically compiler then converts your program. If there are no syntax errors, it then converts this program into a executable bytecode, the machine language code, and that is then executed on your machine, and that then generates these results. So that's the first very basic introduction to C++ program. I'll kind of share the other document with you here, which is basically the Visual Studio Code, and this is the actual program that you saw over there. I'll just go put it in the original form. I think this is the original form. This is exactly the same. As you can see, hash include iostream using namespace std int main, and we can actually just save it. And then if you run this program using the command, where is the command? Run code. So here you can see that the results are basically shown over here. It's going to compile it. It takes its own sweet time, and finally it shows my first C++ program, right? So after you execute it, this was exactly what was written there, my first C++ program. These are different instructions with the compiler. This is the main function from which it starts to execute, and this is your actual code. So it says that, print cout means to print out to the screen. What do you print? You print my first C++ program, then go to the next line, and finally return or complete your program and finish the execution. That's return 0. We'll talk about what return 0 is, what int is, what these other different alphabets are. But for now, if you just execute it as I have done it here, you'll notice that you'll get your first output as my first C++ program, which is very nice. Okay, so then moving back to the Microsoft PowerPoint file again, we noticed that, okay, this was a program that we were running, and in there, that was output that we get as well. So how do you execute a program? To execute a program, you need to use an editor to create a source program in C++. Then you need preprocessor directives that begin with hash and are processed by the preprocessor. And then you need to use a compiler that checks that the program obeys the language rules, as well as it translates your program, which is written in English, into a machine language, that is binary language, or basically come up with an object program specific to your compiler, to your system. To execute a C++ program, what you also need is a linker. A linker is something that combines your object program with other programs provided by the standard developer kit to create executable code. Your program is linked over with the library files, etc., where the library files are pre-written code which we can use. For example, in this case, the iostream was a pre-written library from which we use the cout function or cout code to do something. Then we also need a loader. The loader is basically another program that actually loads your executable program into the main memory and then helps to execute the program. Of course, finally, the program is executed by the CPU, and it finally, after it runs the program, it generates the output, and that is shown back to the user. So these are the different steps that are required to execute a C++ program, and you should actually know them by heart. Whenever you want to write to execute a C++ program, you first need to write it in using an editor. You need to give the preprocessor directives, and then you need to use the compiler, which can basically get to your preprocessor directives, check for them, check for your syntax of your program, and finally convert if everything is legal and the program obeys all the rules, then it should convert them into machine language. After machine language, for execution, you need to link it with your library files and SDK, standard developer kit files, to create some executable code. And finally, that executable code will then be loaded into the main memory for the program to be executed. And then the program is actually executed by the CPU. So instead of doing all of this manually for us, luckily we can use the independent development environments, IDEs, to do this with a build or rebuild command. They have a build or rebuild command. So like just I showed you, I could just run code, and that whole code not only was converted, but it also got executed. So this is the flow chart of how a C++ program is processed. A C++ program is first written into an editor. It is then pre-processed. Then it is given to the compiler. If there are syntax errors or something, you might go back to the editor. Otherwise, if everything is fine, if it obeys all the rules, then you basically pass it to linker, where all the library files that are required by the compiler are also added to the linker. And from linker, an executable file is created, which is then passed on to loader. And the loader then schedules the execution of your program. So that's the overall flowchart of C++, of a typical C++ program processing. So what you need to know is when you're programming, you need to follow the problem analysis coding execution cycle. And this is a very important part of your training. What is an algorithm? An algorithm is a step-by-step problem-solving process where the solution should be achieved in a finite amount of time. So if someone asks you, what is an algorithm? Your answer is, it is a step-by-step problem-solving process where the solution is achieved in a finite amount of time. That's it, nothing. It's not a complex rocket science. An algorithm is simply a step-by-step problem-solving process. It solves the problem, given an input, it generates an output in a finite amount of time for the particular problem under consideration. That's all. Programming itself is nothing but a process of problem solving. You're given a problem, you program it, and that program should ideally solve that particular problem. So the process of converting this particular input to output, that is what is called programming. And programming is always done through an algorithm, which is a step-by-step problem-solving process where the solution is achieved in a finite amount of time. And then if you take this particular algorithm and programming process, I'll basically just think of it as one of the following. So you're given a problem that you want to solve one way or another. You first need to analyze the problem. What does the problem look like? What does it want? Then based on the problem statement and based on your understanding of the problem statement, you need to come up with an algorithm design where you want to come up with the steps to solve this particular problem, the steps that are required to convert your input into the required output for all the possible cases that are there. Once your algorithm is designed, and this I'll always recommend you to do on paper. The algorithm design should be done on paper or in mind, and not you should not directly start coding. So this is something that you should always take good care of. The main problem in most once also you clear this course or you complete this course, you'll notice that the main issue is not in coding itself. The coding is a mechanical part. It's basically the algorithm design and analysis where most people are flawed. And particularly with a lot of practice, I think you'll be able to do an excellent coding part. Then if you talk about the preprocessor directive, after you have done the coding, the preprocessor is going to take over. It will process your code basically to see that all the preprocessor directives are correct. Then basically the compiler is going to compile your code. If some error is found, you might be asked to go back to the coding step and redo it and recheck it. If there's no error, in that case, your program will be passed on to the linker along with the library files will then be added. Linker will then be passed to loader. The loader will then execute the file by the CPU. And in case of no error, you'll find some results out. If there is some runtime errors that are observed during execution, then you might be asked to go back to the coding or maybe to the algorithm design or to the analysis step as well, depending on what type of error was observed and what needs to be done to remove this particular problem. However, if no error is observed, you'll just get the results. And this is the overall cycle of problem analysis, coding, and execution. Some part is problem analysis. The second part is coding. And the third part is the execution cycle itself. And this is a continuously updated cycle. So you need to keep on doing it until this error is removed and you are satisfied with all your results for all the cases. This is what programming looks like. Okay, so if you continue this, the problem analysis coding execution cycle, you observe that the first step is to analyze the problem. We should outline the problem and its requirements. We should design steps or algorithms to solve the problem. Once you have analyzed the problem, you know what the problem is and what are the requirements of the problem, and then you've also designed the steps, or you have come up with the algorithm, the step-by-step process to solve the problem. Then you move on to implementation of the algorithm, where whatever you have written as in rough English as an algorithm or maybe as a diagram, you then need to implement the algorithm in code. You need to code it out just like in English. In a particular syntax. For example, if you're using C++, you need to code in C++. And then once you've implemented the code, you need to verify that the algorithm works. If the algorithm works and everything is fine, then you need to maintain your code. By maintaining, what we mean is we need to use and modify the program if the problem domain changes. So for example, you've made your program for a particular user. If the user changes, you need to modify your program as well for the second person. And that is what we call maintenance of a software. The main steps here is that you need to thoroughly understand the problem and all the requirements that come with the problem. Does the program require user interaction? Does the program manipulate data? What is supposed to be your output? Right? So these are some of the typical questions that arise when you are trying to understand the problem and all your requirements for the problem. What is input? How would the data input come in? How would you manipulate it? What requirements does your program want? And what should be your output? Of course, if the problem is complex, we should always divide into smaller problems that I call sub-problems, into small parts, small chunks. Handle one sub-problem at a time. And once you are done with that sub-problem, only then you should move to the next one. But this is only true if the problem domain is very complex, if there are multiple things to be done, like it was for your midterms when you had them. So we should analyze the data and we should design the algorithms for each sub-problem. Remember, each sub-problem is a standalone problem, and that's how divide and conquer rule works best when you are trying to design and analyze some algorithms. Finally, of course, once you have implemented your algorithm, you need to check the correctness of algorithm. You can test it using some sample data, or you can use some mathematical analysis as well, where you analyze if there is some mathematical condition that is being violated at any place or something, or maybe there's no. You might be studying something in discrete mathematics that might be helpful here, discrete structures course. And so this is some place where mathematical analysis might be required. Of course, once your algorithm is designed and correctness is verified, then you should convert it into the equivalent code in a higher level language. For entering the program, we can use a text editor, or we could use an IDE. Then finally, once you have the code written, you should run the code through a compiler. If the compiler generates errors, which it might do if you're writing the code for the first time, or if you're doing it for the first few times, most probably it will generate some errors. You need to look at the code and remove those errors. Then you should run the code again through a compiler. If there are no syntax errors, then the compiler generates equivalent machine code. And then, of course, the next steps are pretty easy. The linker links the machine code with your system resources. Once compiled and linked, the loader can then place the program into main memory for execution. And of course, the final step is that the program is executed. The compiler at least guarantees that the program follows the rules of the language. There is nothing wrong with the syntax of the code. But it only ensures that the program is following the rules of the language. It's not violating any rules of the language. It's following the syntax correctly. Is it logically correct? That the compiler will never guarantee. That's not the part of the compiler to check if the program will run correctly or not. So for example, let's take the first example, design an algorithm to find the perimeter and area of a rectangle. So you want to find the perimeter and area of a rectangle. The perimeter or the area of the rectangle are given by the following formulas. So perimeter is simply calculated by 2 multiplied by length plus width, and area is calculated by length plus width only, length into width only. So these are the two, let's say, values that we need to be calculating for a rectangle, and these are the processing steps that needs to be done given the length and width. So on our algorithm, if you want to come up with one, is simply stating that first get the length of the rectangle, then get the width of the rectangle, then use the formula of perimeter and find the perimeter. Similarly, use the area variable and determine the area using the formula. So, and finally you need to display it or something if you want, or you might be done with it. Similarly, another example for algorithm is to calculate each student's grade. So let's suppose there are 10 students in a class and each student has taken 5 tests and each test is worth 100 points in total. So we need to design an algorithm that calculates the grade for each student and class average, find the average test scores, it determines the grade as well. So if your algorithm is supposed to do these different tasks, each of these tasks is a standalone task. You can see that calculate the grade for each student and class average. So you need to calculate the class average. Then you need to determine the grade. You might be able to find the average test score, and then finally using the average test score and the class average, you can come up with the grade for the student. What is a data in this particular problem? The data that we require to solve this particular problem is the name of the students, as well as basically the test scores that the students get in all of their tests. This is the data. If you want to determine the average test score, the idea is to get the 5 test scores of a particular student, add the 5 test scores together. So, and suppose sum stands for the sum of the test scores. So the sum of the test scores is stored in a variable called sum. Then suppose that the average stands for the average test score. Then average is simply calculated as, the value in the average is calculated as sum divided by 5. Since there are 5 tests and sum contains the sum of all the 5 tests, hence sum divided by 5 gives you the average of your student. So what is the algorithm to determine the grade? Well, if average is greater than or equal to 90, the grade is equal to A. Otherwise, if average is greater than or equal to 80 and less than 90, then the grade should be B. Otherwise, if this is not true, only then we should check for other conditions as well. And these are all checked together, as I've told you what conditions are. So these are different conditions based on which your grade will be calculated. The main algorithm will be as follows. We start with total average as 0. We repeat the following for each student. We get the student's name. We use the algorithm to find the average test score that was shown previously here, right? This is the average test score. We use that part. Then we use the algorithm to find the grade. So if the average test score or the total sum comes out to be something like this, if average is greater than or equal to 90, this or this or this, so based on that, you are going to assign a grade. And once you have the grade assigned, you're going to update the total average by adding current student's average test score. Whatever the average test score is, you need to add it to the total average. And then the class average can finally be determined after you've passed all the students by basically dividing the total average by 10 to get the class average. So what are different programming methodologies that are to be used? Well, there are 2 popular approaches to programming design. One is called the structured programming and the other is called the object-oriented programming. The structured programming is part of this course, CS103, but the object-oriented programming will probably be taught to you in the object-oriented programming course, which is a core course for CS, CE, and AI students in the next semester. The OOP course may also be taught by me. I'm not so sure yet, but the object-oriented programming course is actually one of the most popular courses of GIK Institute, and we take a lot of pride in that particular course. So one of the courses that, one of the approaches that you're going to study in this course, or the main, let's say, approach for this course is going to be the structured programming course. Programming approach. And the structured programming approach is what is defined as dividing a problem into smaller subproblems. So a structured design is always a design that divides a problem into smaller subproblems. one problem at a time. It just talks about one small atomic thing at a time. And by building it up, it basically kind of solves the problem in a very systematic manner. Structured programming is implementing a structured design, and the structured design approach is also called the top-down design or a bottom-up approach. It can be called a stepwise refinement, or sometimes it is referred to as modular programming in the terms of programming languages. So what is object-oriented programming? Object-oriented programming is a specific programming style that is based on object-oriented design. Here, we need to identify components called objects and then determine how objects interact with each other. Instead of having structured approach alone, it combines things into it. It defines things as objects, and then the interaction of objects with each other determines how the program is going to behave and what is the overall result of it. So this is slightly a different paradigm, and we'll discuss it in more detail in the next semester. But for now, I think it's necessary to know that structured programming technique exists and object-oriented programming techniques exist. The object-oriented programming technique also specify relevant data and possible operations to be performed on that data. Each object in a particular object-oriented programming language consists of data and operations on that data. So each object has two parts. One is the data and the other is, of course, operations. We'll discuss that when the time comes. So for the moment, I'm kind of skipping it for now. An object is something that combines data and operations on the data into a single unit. A programming language that implements object-oriented design is called an object-oriented programming language. Typical examples here are, I think, Java and C++ as well, which has the capability to support object-oriented programming, but it also supports structured programming. So C++ is much more flexible in terms of the programming approach. We must learn how to represent data in computer memory, how to manipulate data, and how to implement operations, right? So there are three things here: how to represent the data in computer memory, how to manipulate or change the data, and finally, how to implement different operations. So in object-oriented programming, we write algorithms and implement them in a programming language. We use functions to implement algorithms. We learn how to combine data and operations on the data in a single unit called an object. So there's just an object, and inside that, the whole data and operations are combined together. Actually, the difference between C and C++ is that C is not designed to implement object-oriented design. It's a pure structured language. While C++ was actually designed specifically to implement the object-oriented design approach. And in the case of C++, the object-oriented design is used with the structured design as well. So C++ contains both object-oriented design and the structured design, while C only contains the structured design. So that's the difference between C++ and C. If someone asks, I don't want to hear an answer that C++ is an advanced version of C. No, it's not an advanced version. They're both two different things. The main difference between C++ is that it's an object-oriented design implemented approach. It was made on top of C in a way that it also contains support for the object-oriented design. That's the main thing here. Okay. So like I said, C++ actually evolved from C. C was the original one, but after some evolution, we now have C++ and C. C++ has changed completely from what C was. C++ was designed by Bjorn Stroustrup at Bell Laboratories in early 1980s. So it's not a very old language, but it's still like 30, 35 years old. And since then, many different C++ compilers have become available to us. The C++ programs were not always portable from one compiler to another. So initially, the problem was that if you made a program for a particular compiler, it was a lot of times not portable, not transferable to another compiler. But because the problem here was there was no standard C++ available. But in mid-1998, ANSI ISO C++ language standards were approved. And the second standard that followed up, which is called C++11, which is one of the more famous one these days, was approved in 2011. And this is the history of the ANSI ISO standard C++. Now we have got a standard C++11 language, which is available for us to use. As a summary to this particular chapter, computer is an electronic device that can perform arithmetic and logical operations. You already know about that. The computer system has hardware or software. So where the CPU or the central processing unit is the brain of the computer, the primary storage, is volatile. So it's the main memory, which is called primary storage. It is volatile. By volatile, it's we mean that the main memory is basically, once you switch off your PC, the main memory is gone. The primary storage is gone. The primary storage, of course, is your RAM. The secondary storage is basically something where your overall data is present, and this main secondary storage is generally permanent. For example, your hard disk, etc., the data is permanently stored there. But in your primary storage, you can never store the data without electricity. It's volatile. It does not work without electricity. The operating system is again a piece of software that monitors the overall activity of the computer and provides services to your PC and to everything. And then there are various different kinds of languages. We have seen some higher level languages, some machine level languages, and other things. So there are various different kinds of languages with which we can interact with the computer. A compiler is basically a machine code and a program itself that translates high level language that you write as your program into machine code. So it's again a program that is just used for conversion from higher level language text to machine code. Algorithm is defined as a step-by-step problem-solving process where the solution is obtained in a finite amount of time. So it does not run on infinitely. It will ultimately come to a solution within a finite amount of time. So problem-solving process basically has three main steps, and those are the three steps that you need to work on. First is to analyze the problem and design an algorithm. The second is to implement the algorithm in code. And the third is to maintain the program. What is a structured design? A structured design is basically a problem is divided into smaller subproblems where each subproblem is solved. And then the solution of the subproblem is then combined together to solve all the subproblems and finally come up with one solution for the whole problem. So structured design breaks up into different smaller chunks, smaller subproblems. That's the only main criteria here. On the other hand, an object-oriented design is basically a program that is a collection of interacting objects, where an object is basically data and operations that are going to be performed on those data. So basically an object is nothing but a collection of interacting objects. An object is data and the operations that are going to be performed on the data stored together. That's what we call as an object. And we'll talk more about this, the object thing, in the course Object-Oriented Programming. For now, it's just enough for us to understand that the data itself and possibly the data for each individual variable, individual person or individual chunk or item, plus the operations that are going to be performed on that data, the possible operations, if you store them together, that's what we call as an object. On the other hand, the object-oriented design is a program that contains a collection of these interacting objects. So with that, we're done with the chapter 1. This is basically going to be one of the revision ones for you. Like this is like the lecture 3. And I'll next talk about chapter 2 for further assistance and for giving you the more help with what needs to be done. Maybe I'll just, for now, I may show you what a typical C++ program looks like, and I can come to it now, I think. So if this is done, let's move back to my compiler. And this was a program that you just ran before. Let's just try this piece of code. So here, again, you have got the preprocessor directives. You've got the namespace std, you've got an int main command. This is your code that needs to be run. It performs a particular purpose. The purpose here is to calculate the area and perimeter for a rectangle. So we store them in some variables. What they are, I'll talk in a minute. This is length variable, width variable, area variable, and perimeter variable. Then we output the length and width. Length is then taken from user, as well as width is taken from user. Then we calculate the parameter using this formula and area using this formula. And finally, we output the length, width, and parameter and area for the user. And finally, we close the program and return 0. That's it. So if you want to run the code, as you'll see, running the code results in enter length and width. So let's enter 12 and let me have 14 as my width. So length is 12, width is 14, perimeter is 52, area is 168. We had a small problem to solve. We wrote a program, we made up an algorithm, we wrote a program, and we were finally able to solve it using our program. And this was written in the Visual Studio Code IDE, which I can maybe show you here. I don't know if it's shown to your screens, but this is a Visual Studio Code. I'm using this particular thing. And I can basically say that using this IDE, which I set up using some command and some things, I was able to run it, run this particular piece of code and get a problem solved. So for any random number of length or any random width, I'm able to find its parameter and the area as well in a quick time. So I wrote this once, but this is so generic that I can use it for any width and any length to determine my area and to determine the perimeter of a square. The problem was, or a rectangle. So the problem was to find the area and perimeter of a rectangle, and this particular code solves that particular problem. So I think this is kind of enough for now for the introductory lecture to computer languages and computer basics of very basic overview of what a computer program looks like. In the next lecture, we'll go into some further details into the basics of a computer program. Thank you and Allah Hafiz.